thank you for joining. Today we're going to be talking about storage devices. To start, we're going to be discussing the Windows file system. New Technology File System is used for storing and retrieving files on drives. Previously, it was FAT or File Allocation Table. However, NTFS has more options than the standard read, write, change, or execute permissions and stores files differently. NTFS also has modify, read, and execute list folder contents as well as standard permissions. Within the NTFS file system, there's the partition boot sector. This is also called a sector, and it can be up to 16 sectors long, which contains information about the volume layout and the file system structures, as well as startup boot information and code. This is followed by the master file table, which contains information about all of the files and folders or directories on this file system volume. In essence, the MFT or master file table is a list of all files and their attributes on this NTFS volume. It's organized in a set of rows and init table structure, which is very easy for the system to read. After the MFT, there's the system file within the file sectors. That contains MFT2, log files, cluster bitmap, and attribution definition table. All of these help with storing data and restoring cached information in the event of a failure. Within the NTFS file system, there are sectors. This is the smallest physical storage unit on the disk. Its data size is in bytes and is a power of 2, and is almost always 512 bytes. Then we have the cluster, which defines the attribute types supported on this volume and indicates whether they can be indexed and whether they can be recovered during a system recovery operation. Finally, we have a volume, which is a logical partition disk consisting of one or more clusters and used by a file system to allocate space. At any time, a volume consists of file system information, a collection of files, and any additional unallocated space remaining on the volume that can be allocated to files. A volume can be all or a portion of a single disk, or it can extend across multiple disks. Next, we have Linux. Linux comes in various types. However, the key concepts follow those of a Unix file system, and should remember that the file system consists of a hierarchical organization of directories. A directory is the same as what is known as a folder on many non-Unix platforms and may contain files and other directories. It's important to note that within Linux, everything is seen as a file. Because a directory may contain other directories, a tree structure is formed. All objects or assumed files are objects in mass storage with the same basic properties. There are familiar positions with create, read, write, and delete. Additionally, within Linux, we have named pipes and sockets. A named pipe acts more or less like sockets and form a way for processes to communicate with each other without using network socket semantics. Sockets are special file types similar to TCP, IP, sockets, and networking, providing inter-process networking protected by the file system's access control. Within Linux, there's one particular file system, which is the BTRFS, and it contains a type of file storage that is a copy on write system, which is helpful with recovery and fault tolerance. When this happens, when a file is written to the system, it saves it in a new location and is copied instead of written back to the same location, assisting with, again, the recovery of an object. To compare, Windows has multiple sectors for easy separation, but can get into a little bit more specific and fine-grained permissions and management. It also is more widespread in enterprises, so is an easy adoption. Linux treats everything as a file. Permissions are more application-level controllers, and on a Linux system or Unix system, everything is a file. If something is not a file, it is a process. However, both of them organize files in a tree-like structure use partitioning for processing and security, and typically come with 512 byte block sizes. If it were to come down to it, I would probably adopt Windows for my organization or enterprise because it is easier to adopt and there's more of a widespread knowledge base in the industry. When it comes to enterprise storage devices, we will primarily be talking about storage area networks and cloud storage. Storage area networks are a dedicated network that provides tape libraries, optical jukeboxes, and disk arrays. To servers and other devices in the network, a SAN storage device looks like a locally attached device. It has a disk block-based storage technology and is probably the most pervasive form of storage for very large data centers, and has been a de facto staple as it relates to database-intensive applications. It also contains shareable storage, large bandwidth, and support from distances across the rack, across multiple racks in the data center and across enterprise locations. It's also wonderful for offline or on-site only data storage requirements, such as in a classified environment. So it's more ideal, especially within the government realm. However, cloud storage has become extremely popular in the private sector. Cloud storage is observing an extraordinary rise in its demand and popularity. Most companies desire to stock their data on some of the other forms of a cloud server, apart from the usual on-premises storage solutions. The most substantial benefit of cloud storage is that it gives you the choice of creating an offsite backup of your data. It is centralized storage of your information, which can be accessible from anywhere. It also is cost-efficient and scalable because it is offered by a third party who typically hosts your information and data. You can rent infrastructure as a service or software as a service in order to store your data, so you can manage the hardware as well, or you don't have to. However, it does require you to be a little bit more specific when restricting access because it is accessible to anywhere, for good guys and bad. From a Christian perspective, the Lord saw that the wickedness of man was great in the earth, and that every intention of the thoughts of his heart was only evil continually. People are supposed to be inherently good. However, many want access to that in which they are not allowed to. Data security should be pertinent within all organizations, and while easy access should be allowed to those that are required to maintain control, permission should be managed well. Thank you so much for joining me in this presentation.